For this problem, we're asked to find the distance between 2 points. The first point being -2, 5, and the second one being 3, 7, and also find the midpoint between those 2 points. So we start by writing the distance formula, which is distance equals the square root of the change in x, x2 minus x1, quantity squared, plus the difference in y's, which would be y2 minus y1 squared. Now, in order to complete the distance formula, we need to identify our x2, x1, y2, y1 from the original points. So we'll go back to the points and we'll just call the first one x1, y1 for their coordinates, and the second one we'll call x sub 2, y sub 2. Now we're ready to put our numbers into the distance formula. So the distance equals, again, a big square root, the second x, which is 3, minus the first x, which is -2. And because it's negative, I'm wrapping it in its own parenthesis, and then quantity squared, plus the second y, 7, minus the first y, 5, quantity squared. So the first time through, what we'll do is we'll first of all make note of the minus a negative will change to plus a positive. And from here now we'll do, inside the larger grouping symbol of the radical, we have two separate grouping symbols of parentheses. So we'll work within each parenthesis. So for the first one we have 3 plus 2 now, which will give us 5 squared, plus, in the second one we have 7 minus 5 giving us 2 squared. And continuing our order of operations, we now square each of those quantities. So 5 squared gets us 25, and 2 squared gets us 4, and finally we add the two numbers. 25 plus 4 gets us 29. Now, because 29 is not a perfect square or have perfect square factors, we're done with our exact distance. But very often in real life, it's kind of hard to measure square root at 29 on a rule, so we approximate that value by using our calculators. So now we put in the square root of 29 into our calculators, and I'll round that to 2 places. I see 5.385, so that will round to 5.39 units. So that's what we get for the distance between the two given points. Now, to do the second part of this problem, we're going to find the midpoint between our 2 points. Again, the points -2, 5 and 3, 7. So to begin with, we'll make a note of what the midpoint formula says to do with our numbers. So the midpoint, first of all, is an ordered pair, and we find it by averaging our two x values, that is, add them up and divide by 2, for the x coordinate of the midpoint, and then average the y's. Again, add them up and divide by 2 to get the y coordinate of the midpoint. So just like before, we'll label our points. So our first point has an x coordinate x1, y coordinate y1. The second point has an x coordinate x2 and a y coordinate y2. I couldn't get it to write above, so I wrote below. Alright, so back to our midpoint formula. So the midpoint is going to be the average of the two x's. So we'll take our x1, which is -2, and add it to our x2, which is 3. Be careful, because usually with the distance formula and slope we're subtracting, but here we're adding, and that's going to be divided by 2. Then for the y-coordinate, we'll take our y's, the 5 plus 7, and find their average by adding them and dividing by 2. So for the x-coordinate, negative 2 plus 3 would give us a 1 in the numerator divided by 2, and 5 plus 2, or I'm sorry, 5 plus 7 gets us 12 divided by 2, which then will reduce to 1/2, comma, 6. So 1/2 for the x-coordinate, 6 for the y-coordinate. Now, a good way to just see if this is in the right ballpark is to sketch these points and see if your point for the midpoint, 1/2, 6, looks about in the middle between those 2 points. I'll leave that for you to do.